Mike coming back at you with another video on discrete mathematics. In the previous video, we saw several sample proofs that we did using the method of direct proof. And we saw how we typically set these things up. We see how we state our hypotheses, and then some basic mathematical operations that are used to arrive at the desired conclusion. In this video, we're going to talk about how to prove mathematical theorems or mathematical facts or mathematical statements in a bit of a different way. What we talked about for the last couple of videos was the method of direct proof. What we're going to introduce in this video are methods of indirect proof. We'll be given some statement or some fact or some theorem, and when you prove it using a method of indirect proof, you're going to not work with the statement that was given to you. You are going to do something with a statement related to what you were handed, and you're going to prove or disprove something with that statement that is related to the one that you were given. That's really what we're doing when we prove something using a method of indirect proof. And we're going to talk about two different techniques of indirect proof, proof by contradiction and proof by contrapositive. So as I just hinted to, sometimes we cannot easily prove a fact using the method of direct proof. It could be a bit ambiguous as to where you would start to write up your proof. Or if you begin to write up your proof and you start to go through the meat of it, you may find that you're kind of on shaky ground. When either one of these is happening, then you may want to take a step back and appeal to one of these two techniques, the technique of proof by contradiction or the technique of proof by the contrapositive. First, we'll talk about proving something by contradiction. A nice bite-sized summary of what proving by contradiction is you're given a sentence, you're given a statement, you're going to assume the negative of it. You're going to assume the opposite of it is true. And you're going to work with the hypotheses of your given statement, as well as what you have assumed to be true. That is, you're going to assume the negative of your given statement. And you're going to use basic mathematical definitions, theorems, facts, to show that two logically reached statements or assertions in your proof totally contradict each other. We'll see that as we go through a sample or two of this kind of problem. So to prove a statement by contradiction, one, you're going to suppose that the statement to be proved is false. That is, you're going to assume the negative of the given statement is true. And then two, you're going to use known theorems, definitions, or facts to show that your assumption leads to a contradiction in logic. This contradiction could be something as simple as saying that the product of two whole numbers is a fraction, or it could be you work with one set of information that you've assumed, you get something, then you work with another set of information that you have assumed, and you get something else, and these two things that you got completely contradict each other. But it leads you to some contradiction in logic, something where you have two cases and both of them can't be happening at the same time. Once you have reached that contradiction in logic, you then conclude that what you have assumed is false, which means that the statement that you were given, the statement that you had to prove, is true. And in our next video, we're going to see how we prove that there is no integer that is both even and odd. We will go through we'll go through the proof of this fact in our next video. The second one here, there are infinitely many prime numbers. If you go on to take a course in theory of numbers, you will more than likely see that proof inside of that course. This is a very basic yet very important result in the world of theory of numbers. We won't do that one in our next video. That requires some other knowledge of facts and other theorems that just aren't in the scope of this course. So that's proof by contradiction. You assume the opposite of what you want to show. You work with your assumptions, and you show that you get to two things that can't be happening at the same time, or just something that is not possible in the world of mathematics. And you then conclude that your assumption has to be false, therefore your given statement is true. The other form of indirect proof is proof by contrapositive. Earlier on in the course, we said that a conditional statement and its contrapositive are logically equivalent. So you may be given a quantified statement that contains a conditional statement inside of it. So it may be for all real numbers, if something, then something else. Well, sometimes trying to work with that quantified statement head-on doesn't really give us any nice leads to work with. But if I can prove the contrapositive of that conditional statement, then because the contrapositive is logically equivalent to the statement that you were given, you are proving that the given statement is true. So to prove a statement by the contrapositive, you're going to express your statement in the form for all x in some set, or we could have more than two guys for all x and y in some set, and then you have your conditional if p of x, then q of x. Step 2, you're going to assume that x is a particular yet arbitrarily chosen element of D, and you're going to assume that not q of x is true. Once you have assumed not q of x is true, you then want to use theorems, facts, and definitions that we know to show that not p of x is true. If you can show that not p of x is true, then you've shown that not q implies not p, and thus its logical equivalent, p implies q. So that's the sort of backdoor way that we show that a conditional statement is true. If you can show that its contrapositive is true, then you're showing that the other equivalent statement, the statement that you are given, is true. And in our next video, we're going to do a couple samples, more than likely these two. We're going to see how we're going to prove that for all integers n, if n squared is even, then n has to be even, and also if n squared is odd, then n has to be odd. We're going to work with the contrapositives of these two conditional statements and see how it's a lot easier to prove these given statements by working with the contrapositive. But that's to come in our next video. So this is just a little bit of an introduction to our two methods of indirect proof. Again, proof by contradiction and proof by contrapositive. Our next video, we'll go through several sample proofs to see how we use these techniques. If you have any questions or comments, be sure to drop them in the comments section below. Otherwise, until the next video, take it easy, guys.